In this lesson, I'll show you how to prove by mathematical induction. This is part 1 of the series. Let's begin by understanding what mathematical induction is. Proof by mathematical induction is a way of showing that a theorem or formula works no matter what. That is, no matter how big or small the number is that you plug into a formula, the formula will never fail. It's a powerful and important technique in theoretical math, which is why we're learning it. The principle behind mathematical induction is the following. Let's let the series S sub n be a statement involving a positive integer, n. So we have S sub 1, S sub 2, all the way to S sub n. If a, S sub 1, where n is equal to 1 is true, and the truth of statement S sub k implies that the truth of the statement S sub k plus 1 for every positive integer k, then the statement S sub n is true for all positive integers n. To prove that S sub n is true for all positive integers n, 2 steps need to be followed. And we'll dedicate part 2 to this exclusively. In part 1, I'll just show you how to write the statements S sub 1, sub k, and sub k plus 1. And with that being said, question 1 reads, for the given statement S sub n, write the 3 statements S sub 1, k, and k plus 1. This is our series, and the general term for this series is shown right here, n bracket n plus 1. With that being said, let's start with the first one. To find S sub 1, we'll set n equal to 1. So I'll set this n and these 2 equal to 1, which gives us 2 times 1 is equal to 1 times 1 plus 1. The left side is equal to 2, and the right side is equal to 2. Now let's find out S sub k, and for this, I'll set n equal to k. All 3 n's will be replaced with k, leaving us with 2 times k is equal to k bracket k plus 1. And the last statement we need to write is k plus 1. So we'll set n equal to k plus 1. We have this becoming k plus 1, which I'll set into brackets. And over here we have k plus 1 plus 1. That's the right side. And for the left side, I'll write down 2k plus 2 bracket k plus 1. Now simplifying this, and the right side gives us 2k plus 2k plus 2 is equal to k plus 1 bracket k plus 1. Now let's try doing this for another sequence. Here is the general term of this series that you see. And once again, we'll write down the following 3 statements. We'll start with S sub 1, where we set n equal to 1. This part becomes 1 to the power of 3, that's 1. And on the right side, we have 1 to the power of 2, which is 1. 1 plus 1 is 2, to the power of 2 is 4. Over 4, and this simplifies to 1. So we have 1 is equal to 1. Now, S sub k. Substituting this with k, we have k to the power of 3, k to the power of 2, k plus 1 to the power of 2 over 4. And lastly, for S sub k plus 1, we'll write down k to the power of 3 plus, for this, k plus 1 raised to the power of 3, and then k plus 1 raised to the power of 2. K plus 1 is k plus 2 raised to the power of 2 over 4. And there you have it. That's part 1 to this series. In part 2, I'll show you the steps to proving by mathematical induction for any given formula. We'll see you soon.